first lesson in our analytic geometry unit is called length of a line segment. When we think of the length of a line segment, we're going to be using a Cartesian coordinate system. So we're going to be using our XY graph. And what I want you to remember is that ordered pairs always go X and then Y. So if we're trying to find, for example, the length of a line segment going from perhaps -3, 1 to 2, 3, if we were going to try and find the length of that line segment, what we would do is look at the ordered pairs. So you can kind of see that the distance between those 2 points, if we imagine drawing in our right-angled triangle, I'm hoping that reminds you of the Pythagorean theorem, where the length would be the hypotenuse, and perhaps this could be leg A and leg B of the right-angled triangle. So what I might do is make this ordered pair here x1, y1, and this ordered pair here could be x2, y2 as the second ordered pair. So thinking back to the Pythagorean theorem, c squared equals a squared plus b squared, I want to show you where the formula will come from that you're going to use for this lesson. We're not sure what the hypotenuse is, but for the height of A, we know that the top here is at 3. So that is our y2 value. And we're going to subtract, so if we're going from here down to here, we're going to subtract 3 minus 1, because we know that this must be 2 units tall. So y2 minus y1. But it's a squared. B squared, now we're looking at the horizontal distance. So the x value of each term is -3 and 2. So what we might do then is also take x2 minus x1, and it's squared. The last step of the Pythagorean theorem is always our answer. So where the formula comes from, it looks just like this, and it looks a lot like the Pythagorean theorem. What we would do is sub in our values if we wanted to find out this answer. We could sub in our values for x2 and x1 and y2 and y1. So our y values are 3 minus 1, and our x values are 2 minus -3. And we could actually subtract. 3 minus 1 is 2. And 2 minus -3 is just like 2 plus 3, so that's 5. And we could find that our answer is the square root of 4 plus 25, so the square root of 29, and that would be an exact answer. Formula is just like the one that we just developed. This is our length of a line segment formula, and we have endpoints, A, x1, y1, and B, x2, y2. Is developed using the Pythagorean theorem. Example 1, to find the length of the line segment AB. Often you're not going to get a graph, but you're going to be given 2 ordered pairs. What you need to do is decide which one is ordered pair 1 and which one is ordered pair 2. So we just have to decide and pick that. So that means this would be x1 and y1, and this would be x2 and y2. So our formula for length looks like this: x2 minus x1 and y2 minus y1. And now all we need to do is sub in the ordered pairs where they go. Subtract my x values first, my x2 and my x1. 2 is 2 and x1 is -2, and we subtract. And then the y's, we're going to subtract -4 and positive 2. And it's squared. So you have to remember things like 2 negatives side by side means that you add, so that's 4 squared. And -4 minus 2 more is -6, and it's squared. So that is equal to the square root of 16 plus 36. The square root of 52, which is an exact answer, we could also find the square root of that, and we put a little dot above the equal sign to say that rounded off, that answer is approximately 7.2. Triangles. When we're given coordinates for 3 points, we can create a triangle using these points as vertices as long as all 3 points are not collinear, all on the same line. So what we're going to explore with analytic geometry is an example that looks like this one. We have 3 ordered pairs given in the question, are vertices of our triangle. So you can imagine what that would look like on a graph, having 3 ordered pairs that create a triangle. And the question is, what type of triangle is formed? So first, what I want you to remember is that we can have scalene triangles. Of the sides would not equal each other. They're all different lengths. We could also have isosceles triangles. 2 sides are the same. And then we could also have equilateral, where all 3 sides equal each other. And so what we need to do to determine what type of triangle this is find how long the sides are. So what we might do first is find the length of AB. Now I'm going to skip writing out the formula every time. I will write it up above. x2 minus x1 and y2 minus y1, and they're squared. So I'm going to apply that formula to all of my lengths. The first one, if I look at A and B, what I might do is use 0 as my x2, and then I'm going to subtract negative 3 as my x1. And then since I used this second ordered pair first, I need to do that again for my y values. So negative 5 minus 2, and that's squared. So what that would look like, 0 minus negative 3 is 3 squared. Negative 5 minus 2 more is negative 7 squared. And so that is the square root of 9 plus 49, which is also equal to the square root of 58. I don't always need to find the decimal answer. Just knowing that it's the square root of 58, I'm trying to compare the other sides to see if they are the same length. So now I might look at the length of BC. Ordered pair B was 0, negative 5, and C was 4, 5. So I'm going to subtract minus 0 and 5 minus negative 5 squared. 4 minus 0 is 4 squared, and 5 minus negative 5 is 5 plus 5, that's 10 squared, which is 100. So we have 16 plus 100, and we're going to find that that is the square root of 116. The first 2 sides are not the same, so it's looking like it might be a scalene triangle. We don't know yet. We still need to find the length of AC. See, the ordered pairs for A and C, A was negative 3, 2, and C was 4, 5. Find is we have the square root of 49 plus 9, which looks a lot like one of the other questions. That is the square root of 58. So when you look at your 3 final answers, we had the length of 3 different sides, and so therefore, because 2 are the same, the triangle is isosceles. Perfect squares might help you, like 1 times 1 is 1, and 2 times 2 is 4. And recognizing those numbers is going to help you more than once in this course. So example 3, determine a pair of possible coordinates for endpoints of a line segment with length square root of 52. How many solutions are there to this problem? Many different solutions to this problem. What we would need to do is find 2 numbers that their squares added up would equal 52. So for example, if I came up with an ordered pair like 6, 10 and 2, 4, and we sub that into our question, I get the square root of 16 plus 36, and 16 and 36, I know, add up to 52. As well, you could think of other combinations of numbers like, I don't know, 8 and 12, and 4 and 6. Because what I know about those numbers, 8 minus 4 is 4, and 12 minus 6 is 6, and when I square those and add them up, again, I get 52. So this kind of question is just letting you know that there are many possibilities of different ordered pairs that would give you equal to the square root of 52.